Okay, let's continue on. I'm gonna just give you a quick history lesson. You will remember that we spoke about Ada Lovelace in week 2 when we were looking at the history of computers, and she is widely believed to be the person who basically created the first computer program. It didn't actually run because the equivalent or the idea that was the computer, that language wasn't yet used. That language computer was only used in the 1950s onwards. In fact, she wrote a program that could be used in an invention called the difference machine or an analytical engine. It's really interesting, don't you think, that the language that we use reflects the time, and effectively she was around at the beginning of the Industrial Revolution. So she said basically that the computer, the analytical engine, has no pretensions whatsoever to originate anything. In other words, it's not creative. It can do whatever we know how to order it to perform. It can follow analysis, but it has no power of anticipating any analytical relations or truth. It's not creative. It's not asking the questions. If we program it correctly, it should be able to give us the right answers, but that's the best. So, what do you think? Is that your view as to where artificial intelligence is going? Do you believe that machines will never be truly intelligent, never truly creative or able to do anything other than answer the questions if they're asked the right way? Most modern computer scientists argue that this view is outdated now, and computer software can develop in ways that can't necessarily be anticipated by the programmers of that software. The lovely, handsome gentleman on the screen here is Alan Turing, and he basically is the father I've mentioned before. If Ada Lovelace was the grandmother, he was the father of modern computing, particularly in relation to artificial intelligence. Amongst many other things, he developed this concept, this test, which we often refer to as the Turing test, back in 1950. And essentially it was a test or the idea of a test to determine whether a machine was able to exhibit intelligent behavior. In other words, to exhibit human behaviors, as that term was understood. So humanity, we call ourselves Homo sapiens. The wise man is what that word Homo sapien means. So it's unsurprising that some of the first attempts at defining what intelligence was, something I talked about in the last video, all tend to refer back to human characteristics. And the most famous of a human-centric definition of AI is basically this Turing test. So in a paper that was written in 1950, Alan Turing asked whether machines could think. And he suggested a game. He called it the imitation game. Some of you might have seen the movie that was given that name. And the game or the exercise requires a human invigilator to try and identify which of two players is a man pretending to be a woman using only written questions and answers. So Turing proposed a version of that game, this popular, cisgendered, very strange game from the 1950s, but he proposed a version where the AI machine takes the place of the man. So if a machine was able to succeed in persuading an invigilator that not only that it was human, and in Turing's original paper that it's the female player, then it has demonstrated intelligence. So modern versions of the imitation game simplify the task by just asking a computer program as well as a few human beings under blind control circumstances to hold a 5-minute typed conversation with a panel of human judges who are in a different room. So basically, humans are speaking to human and machine, and at the end of the conversation, they have to say which one's the machine, which one's the human. And if a computer can fool the human into, or a sufficient proportion of them, mostly this is set at around 30%, but effectively can convince enough people that it too is a human, then it's won the game and the Turing test is passed. Of course, there's a lot of problems with this, I'm sure you can see. It tests only the ability to mimic a human-typed conversation, and skillful impersonation is not the same as intelligence. I could ruffle up my hair, speak with an accent, and say E equals MC squared over and over again. It doesn't matter how good I am at imitating. I am not Einstein. Some of the more successful tests for of the imitation game, the Turing test, have actually involved programmers building in human elements, including typos and figures of speech or frailties, in order to help convince people on the other end that the machine is human. One of the most famous ones, Goostman, which I think I will mention a little bit earlier, basically the machine was pretending to be a 14-year-old boy who didn't have English as their first language. It had crude 14-year-old boy humour, many typos, and odd deflecting tactics, and managed to convince many, more than 35% from memory, of people who were watching or involved in this particular test that it was human. So, Turing test, you need to know about it. Remember that. To avoid the deficiencies in the Turing test, others have suggested definitions of intelligence which don't rely on the replication of just one aspect of human behaviour. So instead, what we're looking at is trying to find different ways of demonstrating this idea of intelligence. Definitions of this type are often variants on the following. AI is technology with the ability to perform tasks that would otherwise require human intelligence. So the Kurzweil task. The term AI itself was actually invented in the 1950s, 1955, in a paper where the lead author was John McCarthy. He has said that there isn't yet a solid definition of intelligence that doesn't depend on relating it back to humans. Ray Kurzweil, who I mentioned before, wrote in 1992, you can tell I'm reading today, can't you? That the most durable definition is the one that we started with: the art of creating machines that perform functions that require intelligence when they're performed by people. Of course, there are problems, and the main problem with this so-called parasitic test is it's circular. It doesn't say a great deal more than artificial intelligence itself. So if you're really interested in this kind of discussion, there's a great book by a guy called Jacob Turner called The Robot Rules, or Robot Rules. It is a really good piece for this particular course. It's certainly not required reading, but I will put in the reading list a link to a video where Turner talks about his book, because it raises a whole lot of relevant and interesting issues. That will be in the reading for next week, when we're honing in more on what the legal considerations are. I think that's enough for this quick little video, and I'll come back in the next video to start talking about machine learning itself, and what it is, and a little bit more around its development and history.